Very good afternoon, everyone. Myself Shraddha Pandya, and in today's lecture, we will discuss how to calculate power consumption of any size reduction equipment, okay, using various laws. So let's start. Example. So here we are asked to calculate power consumption of crusher, right? So a certain crusher accepts a feed material having volume surface mean diameter of 19 mm and it gives a product of volume surface mean diameter of 5 mm. So the power required to crush 15 tons per hour is 7.5 kilowatt. So what will be the power consumption if capacity is reduced to 12 ton per hour? Okay. So here we are asked to calculate power consumption for capacity 12 ton per hour. We have given that power consumption of 15 ton per hour is 7.5. So here we are asked to calculate what power consumption using Rittinger's law. So we all know that in last video we discussed various crushing law, right? Rittinger's law, Kick's law, Bond's law. We have discussed that. So Rittinger's law formula is P upon M is equal to Kr 1 upon dP minus 1 upon dF, where P is what power required in kilowatt, M is what capacity in turn per hour, Kr is Rittinger's constant, dP is product diameter and dF is feed diameter, right? And given data is we have feed diameter that is 19 mm. Okay, so convert this mm into meter, it will be 0.019 meter, right? This crusher reduced the size from 19 mm to 5 mm. So product diameter is what, 5 mm, convert again 5 mm to meter, it will be 0.005 meter. Okay, power requirement for 15 ton per hour capacity is given 7.5 kilowatt. So my P1 power consumption for case number 1 will be 7.5 kilowatt. Okay, M1 matlab for case number 1 my capacity is 15 ton per hour. Okay, and we are asked to calculate power consumption for 12 ton per hour. So M2 will be what, 12 ton per hour, and P2 we have to calculate. Step number 1, calculate Kr. Okay, that is Rittinger's constant, right? Because you can see in my screen, on my screen, that in formula we have P, we have M, we have dP, dF, everything. Okay, but one unknown is what, Kr, Rittinger's constant, right? So for case number 1 we have power required and the capacity, right? So for 15 ton per hour capacity we have power is 7.5 kilowatt. So simply put P is equal to 7.5, capacity 15, okay, Kr is unknown, okay, dP product diameter we have, okay, 0.005, dF 0.019 meter. Okay, so calculate Kr value for from step number 1, and Kr will be 0.00339, approx 0.0034. Now step number 2, power requirement at 12 ton per hour. Okay, so here we don't know what is the power requirement, right? So my P is unknown here. M is what, 12 ton per hour. Kr from case number 1 we have just calculated Kr value, that is 0.00339. dP and dF will be same. Okay, product diameter is 0.005 and dF is 0.019 meter. Okay, so by simply arithmetic calculation you can calculate what power required at 12 ton per hour, and your answer will be 6 kilowatt. Okay, I hope this sum is clear and the concept is clear how to calculate this power requirement of any size reduction equipment using this particular laws. Thank you.